Just want to do a little video series on my solar array installation here. Doing a 9 kilowatt Enphase system that I kind of mixed up myself as 27 mission solar panels that are 310 watts each with a IQ7 plus microinverter for every panel. I'm going to be doing the panels in portrait. They'll be 9 wide and 3 tall. I'm going to be building them here on a rack that's going to be about 6 foot tall on this low end, and I think it was about 14 feet tall along that building edge there. This faces south out here, so they should be in the right direction. I put them at about a 22-degree angle tilt, and I started off here. I originally had some rock on the back here for storage alongside the back of my building, and I'm going to widen that out about 20 feet, well, to 20 feet, so I think I did about another 12 foot out. That was about 8 foot there before. Scraped the sod off that. Got these holes dug. I've got a mini excavator, so made it a little bit easy, but instead of a post hole digger, I just dug these about 4 feet deep, and I used a 12-inch bucket, but you know, they got a little bit wider, so they're probably 14 to 16 inches wide. Some of them are wider than others. So yeah, I've got overall width is 30 foot wide, and then my post space from here to here will be 10 foot spacing, and then I'll have 4 sets of posts. So there's one set there, and then 10 foot over another set, 10 foot and 10 foot. So the overall width is 3 bays or 30 foot wide. And I'm going to be using 6x6 posts, and I'll be drilling through them at the bottom and putting a piece of rebar or two through them to make sure they hold well in the concrete. So that's the start. Once I get the post in, squared up, get those poured, I'll get another video of that. All the dirt that I took out of here, I spread out in some low areas here in my yard, and I went ahead and seeded and strawed that and watered it a little bit. But I also had 2 big trees here. They were, I don't know, 50 foot tall. There was 3 right over there on that corner, and then there was 1 there and 1 there. I took all those trees out. I left this one because it wasn't tall enough to affect the sun, but all the other ones were either kind of dead or too tall that they would block this area when the sun was late in the day there. As you can see, there is a big tree out there that blocks me. It's too big of a tree for me to take down. I mean, it's too nice of a tree. I don't want to lose that, but we'll see. If I see it cutting into my light, you know, that much right there is probably, you know, close to an hour of sun that I'm missing out on. But we'll see how much power I generate and if I want to do something with that later. But before that, the trees that were here, you know, they would have been up here and blocked a lot of sun. So something to think about when you're installing your system is not just the location, but also, you know, that you're going to be pointed south and that you don't have any blockages like that. Over to the east where the sun rises, you know, pretty clear that way. I don't think, you know, by 9 o'clock in the morning, 9 o'clock in the morning, it's over that tree, so should be pretty clear there. Anyway, like I said, I'll get back once I get the post in. Well, here's the post after they were set before concrete. We got the shorter post in, got the header boards on them. The taller posts, we didn't want to get up on those with a ladder until they get concreted in to stiffen them up a little bit, because we'll be leaning on those with a ladder, and just figured we'd wait till we get concreted on those. We had a bit of rain come, so I had to pump all the holes out and dig them out a little deeper to get all the muck out. And to make up for that, I put a concrete block in the bottom of each hole there. So it's just a 3-inch solid block. Had them laying around. See, I punched a little bit of rebar through each post. Got them all plumbed up, squared up, and should be ready for concrete tomorrow. Again, I threw some rock in on top of it, but there's a block on there. We ran these boards out to stakes. Basically, we did this short line first and got them all squared up and nailed off, and then we could basically just tie one to the next. We actually started on that end with this one, and that's why it has the boards on the bottom as well as the angle to hold that one real stiff. And then off of that one we secured this one and down to here, then off of that one to that one, and so on till we got to that one, did another one out. After we got those all supported, then we installed these header boards, and we also cut the tops of the post off to the right elevation, and the header boards are nailed on there. And then that's a 2x10, and then there's also a 2x6 across the top, and that 2x6 will be what the bird's mouth rafters sit on. This horizontal board right here is going to be permanent, and you can see there's some there, the next one back. These angled boards, they just went in while we plumbed up these posts, and we'll just leave them in until we get it all concreted in. And then a lot of these diagonal boards will get removed out of here, and obviously the ones going off out into the yard will get removed as well. And once the posts are solid. So that's it for now. We'll come back once we get concrete in them. Well, there's the posts after they got concreted in. I was starting to backfill them and bring some rock back here, and I figured I'd stop and get a shot real quick. Nothing special. Took all the braces down, poured concrete this morning, already backfilled a couple holes here, but maybe could have ordered a little more. Left each one 6 inches low or so, and ran out from there. But anyway, it's all sturdy. This is 5.5 yards of concrete, so a little over 20,000 pounds holding it down. All the braces are out, and I'm gonna get rock over this whole area here, make it look nice and pretty before I start working the upper part. I started to work the uppers on those tall posts, and just trying to work a ladder on all this uneven ground with all these holes was kind of not the easiest, so I figured I'd go ahead and get this cleaned up, and then I'd have a nice flat surface to work on. That angle right there is going to come out and get a horizontal board like the others. Just haven't gotten to it yet. I'll get back after that's done. Here's the pallet of solar panels I got from Tandem Solar System. Their website's like tandemsolarsystems.com or something. They're Mission solar panels. There's the model name right there. 310 watt. I already took the packing slip off, but got 27 of them. Tell right there are all the barcodes for each panel I received. So that'll go on my barcode map so I know which panel's where. So that way when I'm looking online at the power output, I can see if there's a panel that's not working correctly, you know, which panel it is based off my panel map there. They shipped it by FedEx. I had it delivered to work where we've got a loading dock. They put it in the back of my truck there and offloaded it with a tractor with forks here. I don't know if they've got a weight on here or not, but they thought it weighed around like 1,400 pounds. So pretty good load. And all the cables and microinverters and combiner box and everything from Enphase is up here. So it made this pallet a little uneven. So when we picked it up, we had to be careful, bring the forks in from this side here. if you came in from this side, it was kind of tipsy on the fork. So something to make note of if you're unloading it yourself. Kind of look at it and see where the weight is on it. All my Rafters up, all my Unistrut mounted, all the microinverters mounted, all the Q cable ran, all the wiring from the combiner box into my disconnect, and almost back to my sub panel is done. Run through a couple things here and show you what it took to do. So I have all this Unistrut spaced out to match with the holes in the back of the panels, and I'm planning to mount the panel directly to the Unistrut with 4 bolts, just about in each corner, not quite. And what I did for these to make them the same was I took a 2x4 and I cut 2 of them in the length from here to there, and that way I could set those 2x4s in here and it would get all of my Unistrut in a straight line. So I had one length, it was around 36 inches from here to here. I had 2 of those boards, and then for the space between panels it's a little bit less. It was 18 inches or so from here to there to get those in a straight line. So that made a template, made it the same all the way across. The microinverters, here they are. Real simple. I use stainless steel bolts with the Unistrut spring nut into there. I cut the spring off, and it seemed to be easier to install that way without the spring on the back. Use anti-seize on all the bolts. And then this Q cable right here, my Q cable was for portrait orientation, and that just means each different orientation has a different length cable from plug to plug. So these, order what you need if you're doing landscape or portrait. It came with just enough to stretch from here to here. You can see I bought their Q clips as well. Clipped it all onto the Unistrut rail there just fine. They don't look the best, but there's a lip on the back side there, so they can't come off. And then all the Q cable connects into the AC output, and all the solar panels will connect into the DC output. You can't mix those 2 up. Just the plugs only allow you to plug one in one hole or one in the other. Just 1 bolt up there. I was a little worried about that, but it's sturdy enough, and once the panel's over it won't get a lot of wind or anything else on it. After I ran a branch of 9 here, 9 there, and up top, I've got 27 panels, so I'm calling the uppermost is branch 1, branch 2 is in the middle, and branch 3 is at the bottom here. And all that Q cable runs back. I bought these male and female connectors, so the end of the Q cable was just bare. And I bought this male connector and this female connector, and you wire those together on the ends of the cables, and then you buy bulk cable which has no plugs on it, and that's what's running up the rafters and down into a junction box over there. To save money from doing that, you could have just put an outdoor junction box right here, like a 1/2 inch or 3/4 inch inlet, a 2x4 box at each of these locations, and just switched using wire nuts in there, wiring from the Q cable to like a standard outdoor Romex 12 gauge 12-2 cable. Would have been fine. It would have been probably just as waterproof if you have the right connectors going into that box, and probably cheaper. These connectors were like 15 bucks a piece. But either way, I actually ran out of Q cable, and I had to do that in that box, which I'll show you next. So here I am a little higher up. Failed to mention how I mounted these Unistruts to the rafters. Those are 4.5 inch long, 5/16 inch lag bolts, or lag screws. Each one I read has a 560 pound pull-out force, and there's 11 of them down through the Unistrut here with a pan fender washer. So that should do all right there. Not one of them split the wood. I didn't have to pre-drill any of them, anything like that. They all went in good. So here's the Q cables. Like I said, all 3 branches leading up and going into this outdoor enclosure right here. So this is just a standard 6x6x4 enclosure. Just got it from Menards for $6-7 bucks. Those are 3/4 inch connectors. They're waterproof. They just thread in. I had to drill the holes into this box, and then they have a nut on the bottom, and that's a washer of some sort that's waterproof. And then this top portion spins down and clamps the wire, so it won't let it go in or out, and it also makes it waterproof. So like I said, 2 of these cables run down through this box, down the conduit, and into my IQ Envoy Combiner Box. One of them, because I didn't order enough bulk cable, I had to wire nut inside of here two 12-gauge wires. So I'm not going to open that up, but it's just wire nutted and electrical taped, and you'll see down in here what those wires look like. So there's the IQ Combiner. There's that box we just looked at, and I could have ran those cables all the way down, but I thought this looked a little better, and we keep the cables out of harm's way. If I store stuff back here, I didn't want them getting nicked or anything like that. So here's the IQ Combiner. It's got a safety cover plate over it that I don't have on at the moment, but there's all my 3 branches coming in. So I've got 1, 2, and then this is the other 2 12-gauge cables that I had to wire because I was out of Q cable. So the wires come in. I put all the red ones as L2. Those go straight into the breaker. And if you look on the safety panel, they call this breaker 1, 2, 3, and then 4. You can have a 4th branch as well. They recommended that you can go up to 20 amp breakers for each branch here. Since I've only got 9 panels, it's like 10.8 amps or 10.9 amps. So I went with 15 amp breakers. It doesn't really matter. I watched a video on that, and they said you can do either or. Just make sure you size it for how many panels you're running. This box is good for up to 80, so you can have up to 4 20 amp breakers, and that's the max it'll allow. So, like I said, the red wires come in, and I ran them into L2. There, and then on this one, my white is what I call my red. All the black wires, L1, they need to go through this device down here, which is a meter that meters how much power is coming in from your solar panels. So you can see inside of there, go zoom in, I've got 3 cables going through that in the direction of the arrow. And those 3 cables then go up and into the L1 side of each breaker. There's one, there's another one coming up and going into there, and then this one, which is the other wire, goes up through it, comes down, around over to here, and up into the L1 there. So that will measure how much power your solar panels are making. In this kit, the Envoy is already pre-wired in here. There's the 10 amp breaker for the Envoy. It's got the consumption meter wiring there, neutral wiring there, and this has some Wi-Fi capabilities I haven't gotten into yet that will upload all of the information about production to Enlighten app, which I'll try messing with in the future. Otherwise, here's the cable. After the power comes in here, it comes out through this bus bar here. You've got your ground, your neutral, and this is the cabling that's going to my disconnect, then goes to my sub panel in the garage. So one thing I have left to do is I need to drive my ground rod in here. I'll run a solid ground cable up into here and go into one of these junction bars here, and then I also have to run my ground cable on my PV array, which I got these ground clamps, and it's gonna clamp onto each Unistrut, and then I'll run down this post to this junction box, and then I'll run from this junction box also to my ground rod, so it'll all be tied in and grounded together. So that's it for here. Pretty straightforward. All the microinverters only have 2 wire. The Q cable only has 2 wires. So you don't have a ground or anything like that coming from each microinverter. Your ground is grounded from my rails here or all of your panels and comes into this ground. There's no neutral coming from the inverters. The neutral only starts here with the Envoy, and then also neutral going back to my sub panel in the garage. So real quick, there's my conduit going down the ground, back up, and then a 90-degree box there into the building. That's where the main cable from the PV array comes through the wall there, runs along that 2x6 along the top of the building that the rafters sit on. Just use some U-nails. Runs all the way to the front of the building. And then runs down and out to an outdoor disconnect out there. And then it runs from that disconnect back in, and that's, you see 2 wires right here, and then one is coming down right here, and that one is the one that I will wire into this sub panel using this 40 amp breaker. So I'll get into that later. The electrical inspector here said not to make that final, don't land those final wires until he inspects the system. So I'm kind of waiting on that till last. I'll show you the disconnect out real quick. Pretty straightforward. Here's the panel I bought. It's just a air conditioning disconnect actually. So just pull this out. You can see the terminals in there. There's a bus bar on the back of here. So you turn it this way and it goes in and it makes it on. You turn it this way and it doesn't slide in and it's off right now. There's the wire coming into there. Again, it's just 2 of the same cables, 2 grounds, the 2 neutrals, and line and load going in there. Now the reason this is needed on the outside here is because my meter is over there on the corner of the house right there. And if your house was on fire and the fire station came to put it out, what they generally do, from what I understand, is they would pull that meter out, and that would kill the power going to the house, so they wouldn't have to worry about any of their guys getting electrocuted. Now you need to install a label on that meter that says, you know, PV array, warning PV array, disconnect switch located with an arrow pointing back this way. And then this will have a bright orange or red sticker on it saying, you know, PV AC shutoff or disconnect. And so they would know to pull that meter, then to run over here, open this up, and they could pretty much just pull this out and throw it on the ground. And they'll know that then the power from the array would be shut off as well. Now, theoretically, the microinverters will not generate power unless it's sensing power coming from the grid. So if they pull that meter out, it's not going to be sending power from the grid into the main panel, into my sub panel, back through this disconnect switch, and over to my combiner box and my inverters. So there would be no grid power going back to the inverters, and it would not generate or send back PV power. And there's been some articles on that, whether or not you really need this disconnect. My local inspector and utility company here requested it, so it wasn't much to add, and you know, if it gives them peace of mind, that's fine too. So I'd recommend installing one too, in case you need to work on anything on this end. You can easily disconnect before you go to work on it. You can easily pull out that disconnect there and you'll know you don't have your grid power coming back, so you can work safely in that combiner box out there. So I'd recommend installing one either way. I wanted to do a quick video this morning on the mounting hardware I'm using for these panels. I'm mounting straight to Unistrut, so I've got stainless steel bolt, split lock washer, and a fender or pan washer, and that's just a 1-inch long by 1/4 inch hex screw bolt. And then I've got the Unistrut spring nuts, which I went ahead and cut the spring off. Usually that spring is a couple inches tall off of here to hold it up tight against the channel. And I'm installing these all beforehand and then lifting a panel up there and spinning them into place, so it's a lot easier for me to do that way. So anyway, my Unistruts are spaced out to use the outermost holes. That's that one there and that second hole down there. And on each of these I'm using some of the anti-seize on the threads, so I'll go ahead and paint that on the threads. Thread on the Unistrut nut, I thread it all the way down and back just to get the anti-seize lubricant on all the threads, and then leave it loose so when I go and I lift it up on the racking I can spin it into place. So I set 4 panels yesterday afternoon. It went pretty smooth. Let's see if you can get a shot of them here. This is the 4 that are up so far. I built a little slide rail out of 2x4s that I had, so it's got a stopper at the bottom there to keep it from sliding down the tracks, and then it's got a stopper on top for my first panel. Top for my first panel, and then that's a sloped up, and then a stopper for the second and a stopper for the third. So I'll slide the panel up these boards here, then get on my ladder on this side, slide the panel off the boards and into place. So I'll get another shot of that there. And then underneath here, you can kind of see one of the spring nuts up underneath there. So it goes in parallel with the Unistrut, and then it spins and clamps onto the underside of the track there, and then you can torque the bolt down. Leaving a small gap, you can see there between them, I guess for thermal expansion and whatnot. So I'm going to keep installing these, get a shot when they're done. I've got everything basically finished. It's been up and running for about a week now. Figured I'd go over some of my final thoughts and details here. Kind of explained this earlier, but got the 9 wide by 3 tall and portrait. Ended up putting some extra bracing in here for the system, for the racking I built. X bracing across the back 3 bays. Some additional supports here on these horizontal 2x4s. Some braces in between the 2x4s. Underneath, all the panels are plugged in. All the extra cabling zip tied up or held in with the Q-clips. Everything's been operating normally. I've been making as much as 48 kilowatt hours in a day, and as little as I think 32 on a pretty rainy day. So I wanted to show some of the things that I've redone since the earlier videos. So before I had that junction box up there, those 3 cords there came in through the top of that box, and then this was connected down with this vertical 1.5-inch conduit here, and I just used some standard junction box entries, kind of like how this one's glued in there. It's glued in with like a sleeve inside the box there. Well, I had leakage on the first rainstorm. I believe it was leaking in through those 3 cords and then going straight down the conduit, down the cords, and into this box. So I got that all dried out. I ended up replacing the box up there with a new box from a electrical house that was a little bit sturdier than the Menards version. I put those conduit clamps, which are supposed to be waterproof, on the side. Also packed them full of some silicone and whatnot around the grip too, to hopefully keep that dry. And then these I used at what's called a Myers hub, and those are waterproof metal hubs right there. There's a gasket under there, and then a metal nut on the bottom as well. And so got those in, and then that just is threaded into here, and that part's glued still. Got the stickers added to the box after my inspections were done, and put on the stickers he wanted. Here's the Enphase IQ Combiner. I've got my 3 branches, 1, 2, and 3 coming in. That's the power for the Envoy. There's the Envoy system there, so you can read it in your manual, but the first light there looks like a cloud. Let me see here. That light there looks like a cloud. That means it's connected to Enlighten. The second light right there is if you have this set up as an access point, so you can access it through your phone. That one that's red right there is basically whether or not you're making power. It's pretty late in the day, so I'm in shade right now, so I'm not making any power. And then this last one, I don't know what that one is. That's some sort of uplink. Instructions have what all those mean, but generally during the day, those 3 are all green. Setup on this was easy. One note I had is don't get in a hurry when you type something in, or save a setting on the installer app on your phone. Don't expect it to take change right away. This thing would stop and start and reboot and reload, and sometimes it might take 10 minutes for a change to take effect. And I was sitting here antsy and waiting and wondering why it wasn't working, and it ended up all working fine. It just took a little bit longer. So that's all good. One other comment is this probably wasn't the best. I probably should have gone from here down around the side and then came into the bottom of this box as well, just to keep any water from not pouring on top of all that board there. So that'd be my recommendation if you were going to be installing this somewhere else. The last thing that I went over was the grounding. So I've got a ground clamp here. One's going into the combiner box. One is coming down and going underground, and right here in this area somewhere I drove a ground rod in with a like a Bosch impact hammer with a special bit on it that slides over the rod itself and drives that ground rod into the ground. Couldn't have done it any other way, I don't think. A hammer, that thing was just too flimsy. That was the only way to do it. Then this other wire, ground wire, runs up. You can see it goes up and catches the first rack, runs down my rafter there, catches the next, so on and so forth, all the way down to my last Unistrut here. And I use these clamps. I got those from Solaris.com. Those clamps were real nice and handy to clamp this ground wire on. I did not ground each panel. I figure that the aluminum panel mounted to the Unistrut would carry through this just fine. So I've seen a lot of other people doing that. Iron Ridge racking is even built that way, so I don't see why Unistrut wouldn't conduct the ground just as well as Iron Ridge. So I'll do one more quick video of my net meter, And I think this will wrap it up. If you guys have any questions, leave them in the comments or shoot me a message. This is my sub panel back in the garage. Inspector had me put that sticker on there, and if you open it up, it also has a sticker on the breaker going to the solar array. It's 40 amp breaker, and then labeled it in there as well. That same kind of sticker is posted out here on the AC disconnect. So this is what the utility company or the first responders would use to shut off power. I showed that in an earlier video, but just added the stickers. And then if I walk over this way to my net meter, and they installed this no problem with, it didn't even shut off power to your house. So I guess they just change out the meter and the connection stays going. So again, added a couple stickers here to that. And then this meter, so it says received, so that's how much I've sent to them. So I've sent them 82. I don't know what that is. And then net, so that's the difference of what I've used versus what I've sent them, 71. And they've delivered me 154. So they've sent me 154. I sent them 82. And so the net that I owe them, which I'm in debt to them right now, is 71. And our power here runs about 12 cents a kilowatt hour. So, I owe them about $9. And it's been running, well, they put this meter in on Friday morning, and now it's Tuesday late in the afternoon. So, around $9 for Friday, Saturday, Sunday, Monday, Tuesday, 5 days. So that's pretty good. I used to run on a weekend, I would use about 100 kilowatt hours in a day. And now in 5 days, I've used 71 kilowatt hours. So cut it down substantially. I'm happy with it. And that should only go better throughout the week, because again, that was over Labor Day weekend, which was Friday, Saturday, Sunday, Monday. We were home, running laundry, running the air conditioning, things like that. And during the week when we're away from the house at work, it'll be generating power while we're not home, sending that back, and the received number should go up while the delivered number would go down, and it would make my net smaller, so I will owe less. So I expect to see, next week that it's possible the net amount could actually go down. Instead of saying 71, that could be 50. So again, that's it. If you guys have any questions, just shoot me a message. Thanks for watching.